Welcome to our channel, Moto Mouths Uganda. Today we are going to talk about ABS. I don't want to unravel what our resident expert is going to break down, so I will wait for him to tell us what it is. But in the meantime, for me, I know it is the initials of my names. Otherwise,
Alan Brand
we
Fenyonga.
are, yes.
I don't know any acronym in the automotive repair industry.
Since we are talking cars,
That
he's going to
is,
tell us what it means and what it does, how it operates, so that it ceases just being something we see and we don't know what it is supposed to do on the cars or how it does it. Welcome, Engineer Ivan Chuwuka.
thank you. Unfortunately, like I was saying, I don't remember any acronym in the automotive industry that follows mine, IKK. So I'll look for something. I'll try to dig up something. Yeah. Uh, Welcome, our viewers. Good afternoon. Today, I'm going to discuss ABS. ABS in full is anti, or like Americans say it, anti-locking. It's one word, anti-locking. Then braking systems. So you get ABS. As usual,
Mm.
I'm going to share a presentation about this. I'm hoping you can see it now.
I can see it loading. Yes, it's now visible.
Yes, anti-lock braking systems. Like I mentioned, a lot of you see it on written on cars, ABS, ABS. Yeah, that's what it means, anti-lock braking systems. So, yeah, what are they for? Uh, under normal braking conditions, normally wheels don't lock, we brake normally. But in emergencies, if you're going too fast for the road conditions, or the road surface is very slippery, some wheels or all wheels may start skidding. So if one or more of the vehicle wheels locks, that is, it stops rotating or otherwise begins to skid, then this has a number of consequences. The braking distance increases because your brakes are no longer working. Your vehicle is just being dragged across the road surface. Steering control is definitely lost because now you can no longer steer. Regardless what you do with the steering wheel, the vehicle takes um, whatever path physics is dictating. Um, you remember, I think it was one of Newton's laws of physics. Everybody continues in its state of motion until acted on by another force, something like that. So that law of motion takes over and the vehicle takes whichever direction physics, physics dictates. So you are no longer able to steer, and that's the most dangerous part about it. Of course, tire wear becomes abnormal. That may not be extreme, but it becomes abnormal because once the wheel is just skidding on the ground, part of the rubber is being burnt away in that area, depending on which portion of the wheel was in contact with the road surface when it started, when it locked. Um, the obvious consequence is that an accident is far more likely to occur, especially because you can no longer steer. So now, this graphic explains or tries to explain what happens. Assume in both cases, the road surface is slippery. Um, if you don't have ABS and you applied the brakes and the wheels locked, the vehicle would continue kind of in the direction that it was going, most likely in the direction that it was going when the wheels started, when the wheels locked. And that may not be desirable, especially if you're going through a turn So you are going to go off-road and have an accident. Whereas a car with ABS will prevent the wheels from locking, so you are able to continue steering. Even if it is a turn, like you can see, this is a right-hand turn, the vehicle can continue. It doesn't mean you kind of start doing daredevil things with the vehicles just because you know you have ABS. No, it's just some system that has been installed on most modern vehicles to increase safety. If you find yourself suddenly um, in a bad situation where you have to brake suddenly and also have to continue steering. So how does ABS operate? It can be considered, the ABS system can be considered as a central control unit with a series of inputs and outputs. The most important of the inputs are the wheel speed sensor. They are not the only sensors involved, but they are the most important. And the main output is some form of controlling the brake pressure for each wheel, each tire separately. There are some older systems where the rear axle or the rear wheels were controlled together, but the majority of vehicles now, for the majority of vehicles now, each of the four wheels on a normal car is controlled separately by the system. If it is a truck, like a semi-trailer, the same thing applies, but where you have two wheels together on one side of the axle, yeah, those tires will be controlled together, definitely, because they are on the same hub. So the task of the control unit is to compare the signals coming from each wheel sensor. So it will look at the wheel sensor will be looking at the wheels and making sure that all wheels are turning at the same expected speed. It has some logic. It can even tell whether the speed you are doing is not normal. For example, most of these cars, on most of these modern cars, the control units, the computers on the cars, communicate between themselves. So if the transmission control module says you are doing 80 kilometers an hour and the ABS module is looking at you, the wheel speeds are reporting 140, it may realize it's a problem. And also for modern cars, vice versa happens. Sometimes you get, increasingly on many cars now, you get gearbox performance problems, transmission performance problems when you have issues with the ABS because things are not adding up. What the transmission is seeing and what the brake system is seeing, the ABS system is seeing, do not agree. Sometimes you get issues. So just know that the main signals are the ABS wheel speed sensors, and that's what the computer will use to make a decision on what to do, whether to interfere with your braking or not to. And as we shall see later, these speed sensors are also very important for traction control, which we shall be discussing in the next video. But anyway, from this data, brake pressure to one or more of the wheels can be regulated depending on the logic in the control module. Brake pressure can be reduced, held constant, or allowed to increase. The maximum pressure is determined by the driver's pressure on the brake pedal. So here is an example, an analogy to ABS application. Alan, I don't know if you can see the dog on the right does not have ABS, so it is skidding across the sand. But the one on the left has ABS, and you can see it can even control its direction. Both dogs are being pulled by the owner into the water, something of course, they would not enjoy, so they are trying to resist. But one has applied ABS while the other has not. But you see, the one that applied the equivalent of ABS, you can see it even change direction. So it manages to steer, while the other one, which is being dragged across the sun, is only going in a straight line. The next schematic is about shows the components of a typical ABS system. If you look at the bottom on the wheel where my cursor is, that is the wheel speed sensor. There's always the sensor always is reading some teeth. Sometimes they can be teeth on like a gear wheel that is rotating with the wheel. That is in the older systems. In the new systems, it's usually a magnetic ring that the sensor is reading off. The advantage is that with the magnetic ring, it can even tell which direction the wheel is spinning. It can tell the speed of rotation and also the direction, whether you are going forward or backward. There are other reasons also why it has been, they have upgraded from the gear teeth type of activation to using the magnetic ring. So you have the signal going up to the ECU. So when the ECU notices that the wheel is about to start slipping compared to the other wheels, it will command the modulator to pulse the brake pressure for that particular wheel, and that brake pressure will be applied. Usually it is reduced brake pressure, will be applied to the brake caliper, and then the wheel will be released. If it was about to lock, it will be released and it will continue rotating. While the other wheels are getting full brake pressure, this one will kind of receive reduced brake pressure, continue to spin, and that allows you to continue steering. The moment it realizes that the friction, the tire has enough friction again to be able to take more brake pressure, it will reinstate the full brake pressure from the applied through the pedal from the driver's foot. So that's why you are seeing the brake pedal here and the master cylinder. The pressure will go, the applied pressure by the driver will go to the modulator. And if the ABS system does not intervene, either because the system is happy with all the wheel speed sensors and it does not require to activate, or if the system is faulty, again, it will not do anything. All the pressure you applied from the pedal will go to the wheel. But if for some reason it wants to reduce the brake pressure, like I've explained, on one particular wheel, just for that wheel, the modulator will reduce pressure on that wheel. I don't want to repeat myself so much, but I think you now start to get the idea of what is going on. So the function of the ECU is to take in information from the wheel sensors and calculate the best course of action for the hydraulic modulator. Between you and me, just know, it's very, very rare for ABS to kick in. Very rare. In fact, most times when it kicks in, you know it because you get feedback through the pedal. Usually, it will usually be an emergency where the car is kind of about to skid, and then you feel the pedal pulsing, pushing you back, but in pulses. For most normal driving, the ABS system is just there watching. It never needs to kick in. Anyway, the heart of the modern ECU consists of two microprocessors which run the same program independently of each other. So this is an introduction of redundancy into the system. So if one fails, the other is able to take over, but it will the other, you will still be protected. When they disagree, I think they will set a fault code, and then you have to fix the ECU itself. Anyway, this redundancy ensures greater security against any faults which could adversely affect braking performance. Because the operation of each processor should be identical, if a fault is detected, the ABS disconnects itself and operates a warning light. You now have normal braking. So if you have an ABS warning light on your dashboard, it doesn't mean that there's a problem with your brakes. Your brakes will continue functioning, except you will not have ABS activating when you need it. So the vehicle will continue operating as if it doesn't have ABS, as if it was never made with ABS. But in case of an emergency, you will not be protected until the problem is fixed. So the ECU performs a self-test every time the ignition switch is switched on. A failure will lead to a disconnection of the system. Like I said, if it notices any sensor or any electrical component of the system, the ECU will disable the entire system. Even if it is just one sensor that is faulty, it will lead to the entire system going into fail-safe mode. It will not operate. So for you to continue enjoying the benefits of ABS, you have to fix the vehicle or keep the vehicle in such a condition that everything, the entire ABS system is working properly. All the components, sensors, valves, the mechanical braking components are working properly. The following list forms the self-test procedure or process. It will check for the power supply, exterior and interior interfaces, like I said, the sensors and all. Transmission of data, I hinted on this. An ABS module will probably be communicating with the transmission module, with the engine control module, especially if you have traction control, as we shall see in the next video. It will also be communicating with the instrument cluster on your dashboard to warn you when there are issues or when the ABS is active. The four-wheel drive module for modern cars with all-wheel drive, like Audis and Mercedeses. So it also checks the operation of valves and relays, the operation of fault memory control in case it has recorded any fault in the past. And that's one reason why it would keep on the ABS warning light, and also reading and writing functions of the internal memory. And all these checks at the start of the vehicle or at the when you switch on the ignition key. All this takes about 300 microseconds. That is about 0.3 of a second. That's very, very quick. Even your eye wouldn't catch it. That's why if there is a problem with the system, the moment you turn on the key, you will see the warning light already on the dashboard. So the hydraulic modulator has 3 operating positions. Now the hydraulic we have the ECU, which I have just described, which is like the brain. Then we also have the hydraulic modulator. You will see in the next few slides, you will see what both of them look like, because usually they come as one unit. There are 2 components, but come in one unit. So the hydraulic modulator does the ECU does the soft part, and then the hydraulic modulator does the heavy stuff. It is the muscle in this case. The ECU is the brain, then the muscles is the hydraulic modulator. The modulator has 3 operating positions. Either it will build up pressure where the brake line is open to the pump, because there is a pump involved here. When ABS is operating, there is an ABS pump that is activated. And then it can also hold the pressure, even though your activity on the brake pedal is changing a little bit, because most times in emergencies, we cannot hold the pressure for us humans, we feel we are piling onto the brake pedal, we are piling on exactly the same pressure. But usually it may vary depending on what exactly you are doing. If you are heading into a crash and maybe you are shouting, your pressure on the brake pedal may not be the same. But these systems are smart enough to realize you are still pressing the brake pedal, so they may hold the pressure as you continue braking. And then there is the other operating position of pressure release when you release the brake pedal altogether at the end of the ABS intervening. This is where the brake line is open to the reservoir, and whatever brake fluid was pressurized in the system is let into the reservoir, back into the brake fluid reservoir, because it's no longer needed. The valves are controlled by electrical solenoids, which have a low inductance, so they react very quickly, faster than you blink your eyes. The motor only runs when the ABS is activated. I hinted on that earlier. We have a schematic here showing the three phases of hydraulic modulator operation. The image on top is where there's a normal build up or build up of pressure. You have a pressure from the master cylinder. The foot is, or the brake pedal is somewhere or to your right. Then the pressure that you apply on the brake pedal is fed through the master cylinder, is fed to the modulator, and then consumed or used by the system, depending on what's going on. In the second image is where a valve has closed off the pressure from the master cylinder and also to the accumulator. That way, the system is controlling the brake cylinder caliper, the position of the brake cylinder caliper, and therefore how much effort is being used to brake that wheel. So it takes control of the brake pressure in that wheel, and then it can play with that pressure independent of what the driver is doing. That way it can prevent, it also continually looks at the wheel speed sensor. So things keep changing very quickly to ensure that the wheel doesn't lock. And then in the third image at the bottom on the right is where the brake pressure is no longer needed, and the modulator allows the brake fluid to go to the to go back to the accumulator, to be released back to the accumulator. And that's why you see the spring in the first two images. The spring in the accumulator is kind of pressed in, but here it is released. It has been allowed to relax and allow brake fluid back into the accumulator. So usually that is what you see of the ECU and the modulator. They usually come as one unit. For many vehicles, at least from the 90s and early 2000s, sometimes when the ECU is bad, you can change only the ECU and keep the modulator and vice versa. For many newer vehicles, it's hard. If the ECU goes, you have to change it along with the modulator. But they generally look like that. So if you opened up your car and the front, you'd see, if you see a component that looks like that, that is your ABS control module. It is also your traction control module if the vehicle is fitted with traction control, which I'll explain in the next video. And that what looks like a drum is a modulator. Yeah, thank you for your patience. I now invite any comments and questions from you, Alan.
Thank you for that detailed explanation. A bit complex for some of us. However,
Yeah, I
it is very
invite our
necessary.
viewers to, if I know I always go too fast, but that's because we don't want to make these videos too long. I invite our viewers to forward and rewind and whatever. They can take their time to go back and forth. I know I'm going too
Absolutely.
fast. For anybody who is learning about this for the first time, I know I'm going too fast, but then there are some other people who grasp this content very quickly. We don't want to bore them. So our viewers are free to rewind and forward the content.
Absolutely. I was saying that this content is very important because the braking system is usually that thing that, in most cases, saves us from danger. So it is very important to understand how it works and to know faulty so that it is addressed quickly. Yeah? We have this tendency of, I know my car, then the lights start coming on the dashboard and someone is still insisting they know their car until the car
Yeah,
shows them
especially
that it.
because when the ABS light comes on, many times the car feels normal. That is because it will brake normally simply because ABS is not required in normal driving. You only understand its importance in an emergency.
Mm. So yeah, it is very good that you have broken down these things. Hopefully, our viewers will understand better. They can comment, ask more questions about any bit of the content that they find maybe confusing. Thank you.
Yeah, there is something I wanted to hint on that I have just remembered. I hinted on it earlier uh,
Yes.
in this presentation. For many cars now, when you have an ABS fault, you are also likely going to have faults in the transmission and the all-wheel or four-wheel drive systems if they are electronic. Yes. And also sometimes you are going to lose functionality of some parts of the drivetrain. For example, if you have cruise control, it will be affected. On many cars, it becomes affected. If you have traction control, it will not be functioning. I had an incident several months ago where the magnetic ring on my rear right wheel disintegrated, I think out of age. So the rear right wheel speed sensor was not reading properly. I had lights come on. Immediately I was driving along near Katwe, along Luiri Ring Road. I had lights come on. The engine changed the not power. It kind of went into fail safe. And then when I started turning into Katwe, that's when I realized the steering was now stiff. I didn't know at the time what had happened. The vehicle was still drivable, so I continued until I reached the garage. And then we diagnosed the issue. It took us about 1 hour, 2 hours to pinpoint what the issue was. But there was an error with reading the speed on the rear wheel, on the rear right wheel. But that disabled so many things, including power steering, because power steering on most of these modern cars, I drive a 2019 Renault Duster. So it has electric steering. Most of you have electric steering now, by the way. Most Toyotas from around 2008 and 7, they don't have the normal power steering, hydraulic power steering that you are used to. They have electric. So even this was affected. And once we got a new ring and fitted it on the vehicle, and the sensors read the correct data, everything went back like nothing happened. But 3 or 4 systems had gone out. You could not use cruise control. You could not use the steering became hard. Traction control was lost. Yeah, so a failure in one system can lead to failures in other systems. So it's no longer easy to ignore some of these things. In the earlier 90s cars, even those with ABS, you'd have an ABS fault, light comes on, but life continues. You drive and the car would be normal. I think the manufacturers are putting logic into these control modules to force you. For example, I was wondering why was the car forcing me to drive with a hard? Why was it disconnecting? Why was it disabling the electric steering? I don't know what the logic is, but once we fixed the issue of the ring, and this is where you get uninitiated mechanics who are not knowledgeable about these things we are teaching. Your steering goes hard, they'll go into the steering system, sell you a steering rack, mess around with the electronics related to the steering, go into the gearbox. For example, if the vehicle is not changing gears, why wouldn't it be changing gears? A lot of transmission control modules now rely on the readings of all four ABS sensors. They take the average of all four wheel speed sensors to be more accurate than the speed sensor in the transmission, because the speed sensor in the transmission is 1, and you can even have it giving what looks like good data when the wheels are actually in the air spinning. So 4 wheels and with 4 sensors sending the same data is a better confirmation of the actual speed than the speed sensor in the transmission. That's why many manufacturers are now doing it like that. So please watch out for these things. When your warning lights come on your dashboard, better fix the car and take it to people who know what they are doing. Because many times a lot of people get problems with their cars because they begin with a small problem. Like in my case, the problem was just the magnetic ring in the hub. But we spent 2 hours, me and Mubarak, diagnosing it, and we pinpointed where the problem was coming in, what was coming from. Because we had the knowledge, we had the tools to measure signals. We also had wiring schematics and repair manuals. So we had references. So, and we imported. Rhinos are not common here. So I had to import that ring. It's not expensive at all. It costs about 20 pounds from the UK. And that solved the problem. If that vehicle had ended up in any other garage where they are not initiated yet about these things, they could have messed with the wheel, of course, with the brake system. They could have gone after and messed with the steering system. They could also have messed with the transmission. Yeah, so our viewers, that's why we make these videos. It's good if people who are in the repair industry, who are repairing vehicles, like other mechanics, technicians, can come and consume this. But we make these videos mostly for you guys, the owners of the vehicles and the drivers, the normal person. That's why I try to break down these things into easy to understand elements. Yeah. Thank you for your time. I'll wait for comments from our viewers regarding this subject. Thank you and have a good afternoon.
Thank you too.